In this video, we want to consider vertical motion, which is any motion that is under the influence of gravity. Now, there are laws that govern this vertical motion. The first one is that when a body drops or freely falls, it means that initial velocity, is zero. The second one is that at maximum height, final velocity is zero. The third one is that acceleration due to gravity is always negative. So the fourth one is that when a body goes up, height is positive. But when a body comes down, height is negative. The reason is because when the body is going up, the height is increasing. When it is going up, the height is increasing. But when it is coming down, the height is decreasing. If this is the floor, the height is from here, it's coming down. You can see the height is decreasing until it gets to. So when it is going up, the height is positive, it's increasing. When it is going down, the height is negative. The fifth one is that final velocity continues to increase as a body continues to fall. So let's look at upward motion when a body is going up. There are some things we can calculate when a body is going up. The first one is time to reach maximum height. Now, we saw that one of the equations of motion is that v is equal to u plus at. Now, because we have vertical motion, this is vertical, the y-axis, this is x-axis. So we're going to use v as y to show that it is vertical like this. And we're going to use u as uy just to show that. And we're going to use a as negative g, and we're going to use t as still t. So because of that, we can rewrite this equation as vy equal to uy minus gt. So minus gt. So that's how we can write it. And this equation is if the body didn't reach maximum height, we use this equation. But at maximum height, then it means that final velocity, initial velocity is zero. At maximum height, this is zero. So because of that, we can say t becomes t max. So t max is equal to uy over g. So because at final velocity is zero at maximum height. Final velocity is zero. So this is zero. Make the subject of the formula. We'll get this. Another thing we can calculate is the maximum height. So at maximum height, if we consider this equation, v squared is equal to u squared plus 2as. If we consider this equation from motion, now this is vy, this is uy, this is negative g, and this is now h. The distance covered is now h, height. So we can rewrite this as vy squared equal to uy squared. This is minus g times this, it becomes negative gh. So this is at any point. It has not gotten to maximum height. So we use this equation. But when it has gotten to maximum height, this person becomes zero. So if this person becomes zero, we can now say that this is now h max. So we can now have that zero is equal to uy squared minus 2gh max. So from there, what it means is that if this crosses over, 2g h max is now equal to uy squared. That's what it means. So from there, we can make this subject of the formula. H max is now uy squared over 2g. So this is formula for maximum height. If we consider downward motion, the technicalities are different here now. That's the opposite of this one. The first one, we can calculate time of fall. Time of fall. So if we use the formula that says ut plus half at squared. Now remember, it is falling, so this is h equal to, this is u y, so u y, this is now t, time of fall, so we say time of fall. Now this is minus g, so it will affect all of this, minus half g t f squared. Now remember, height, this is down. As it is coming down, height is decreasing, so h is negative. So always consider that. This is formula for height. But if the body drops freely, or it falls freely, it drops or it falls freely, what it means is that this is now 0. And if this is now 0, we can have that h is now equal to 1 over 2 GTF squared, because here is now 0, and if it multiplies this one is also 0. So what is left is only this side. This minus will cancel out this minus, so we have only this left. If we now make this subject of the formula, TF squared will now be equal to, this is square, remember, it will now be equal to 2, because if you cross multiply 2h, so 2h over g, and only t alone, because this is t squared, only t is now square root of 2h over g. So this is formula for time of fall. The next one we can consider is final velocity. Final velocity. From the formula, v squared is equal to u squared plus 2as. We can transform it saying y squared is equal to u y squared. Since here is negative, this is now h, and is also negative because it's falling down. So negative gives us positive. So we say positive 2gh. So this is negative, multiply two of them, they give us positive. But if the body falls freely, what it means is that this is now 0. If it falls freely, then we'll have that vy squared is equal to, since this is g, what we'll have left is here 2gh. That's v alone will now be square root of 2gh. So if it falls freely. Now before we go into calculations, let's just talk about range briefly. Range is the only horizontal component of the vertical motion. So we have that r is equal to, so we're not going to use x because we're talking about the horizontal distance now, because this is the only horizontal component of a vertical motion. So we're using x now, because so t minus 1 over 2 gt squared. So remember that for a horizontal motion, gravity is always 0, and because of that, everybody here is 0. So what we have left is only this area. So we have that ux times t. This t is equal to time of flight. This question says a ball is thrown vertically upwards with a velocity of 40 meters per second. Calculate the time to reach half of the maximum height. Now, since we were not given the maximum height, we know that to calculate maximum height, it is given as u squared over 2g. So we need to find the maximum height first. We were given the velocity to be 40. So 40 squared over 2 times our g is 10. This will give us 1600 over 20. So this will give us 80, because this cancels here, 160 into 2 is 80. So maximum height is 80, so half of that maximum height will now be 80 over 2, which is 40 meters. So having gotten half of that maximum height, let's bring out the parameters. U given to us 40 meters per second, the g 10 meters per second squared, then the height that we're going to use, which is half of that maximum height, is 40 meters. Then For us to find the time, time is given us from the formula V equal to U minus GT. If we make T subject of the formula, T becomes U minus, this one comes over minus V over T, okay, over G is close to T, so over this. So but we don't know V, so we can't use this yet. We need to find V first. For us to find V, we say V squared is equal to U squared minus GH, sorry, 2GH minus 2GH. So V squared is equal to 40 squared minus 2 times 10 times H that we're using now is 40. So V squared is equal to, this is 1600 minus all of this area should be 800. So we have that V squared is 800 and V alone is root 800, which should give us about 28.28 meters per second. So having gotten that, we can plug it into this place. So T is equal to, our U is 40. 40 minus 28.28 over G. G is 10. And if you calculate that, you'll be getting 11.72 over 10. So which one decimal place, which is 1.172 time seconds. So like my video, share, and also subscribe to my channel. Thank you.